Okay, section 9.10, absolute value inequalities. Okay, what I want to be apparent is that we're still dealing with absolute values. So obviously the first thing that should come to your mind is absolute value still denotes distance. Okay, so what does that mean? How is this any different than the equalities that we were dealing with? Well, there's really not much of a difference, but there are a few little intricacies that you're going to see here in just a little bit. If you'll notice that basically this right here is still just the same from our last definition. This right here is still just the same from our last definition. So really we're not going to have too much problem. So let's just do some examples that we kind of see, because that's where you're going to get the meat of this, is really by the examples in this one. And most of this isn't hard, as long as you just kind of pay attention that these aren't equalities anymore. These are now inequalities. They're going to be, you are stating different things now. So let's look at one real quick here. Okay, we've got x is less than 3, which means obviously that we're going to have a 3 on this side or a negative 3 on this side. It's no different than whenever we had the absolute value of x equals 3, that we could have x equals 3 or the absolute value of x equals negative 3. But now we've just switched it to a less than sign. What does that mean? Well, if we read this, look what it says. X is greater than negative 3, which comprises that right there. That is the x is greater than negative 3. This right here, x is less than 3. Well, that comprises this area right here. X is less than 3. Did not want to mess up on my notation there. And then our interval notation. Notice these right here mean open brackets. So the interval notation is negative 3 to 3. X can be greater than negative 3 or less than 3, but not negative 3 and not 3. That's what this is saying. Remember that. That is going to become very much more important, and sorry for my horrible English there, as time goes on. If this is not just your last math class, if you're going to keep going on, that will become more and more apparent in how important that is later on. Okay, so moving on here, let me kind of give you like a little note here. Just remember that x, which is that right there, can be anything in between that area right there. And another little side note that we'll kind of get to here, I want you to recall, obviously, as we stated up above, absolute value is a distance. So distance is always non-negative. Okay, that's just a fancy math word that it has to be. It can be 0 or more. Okay, just a fancy math word. So if you run into an equation that says, let's say you have x plus 9, I believe this is a example in your book, is less than negative 1/2. That's not possible. Okay, because you cannot have a distance that's negative. Okay, we learned that whenever our very first lesson about absolute values is, remember, if I'm standing on a point and I go in the negative direction, the direction is negative, but how many units I go, that's always a positive, because this is absolute value. So if you run into something like this, it's going to have no solution. I'm moving on. Another little example with the solution. And I'm doing these for a reason. I wanted to kind of show you the solution before we actually start doing some examples. Look how this absolute value of x is less than or equal to 6. Okay, same thing like the last one. Okay, except this one right here, if you'll notice, this one will be closed. So it would, x is going to be anything in here is going to be x, including -6 and 6. Okay, and then this right here is obviously your interval notation. So yeah, let's do a couple of examples and see where it goes from there. Okay, notice that this one right here is not in standard form yet. So just like we did in the last chapter, we need to get this thing in standard form. So what we're going to need to do first is let's divide off this 3. Okay, because we do have a multiplication here. The inverse of multiplication is division. That is going to reduce that down, and you're going to be left with 2x minus 7 is less than 5. Okay, now to make this easier, instead of just writing out this twice, you can always do this. Look, I can add a -5 right there. Then we would just solve both sides of the equation. And then to do that, just add 7 here. And what we do to one side, we have to do the other side, and now to the other side. That is going to reduce this down. Okay, what are we going to get over here? We're going to get -5 plus 7 is going to be a 2. Copy down exactly. Okay, a 5 plus 7 is going to be 12. Okay, now we have a multiplication here. We still got to get that x by itself. I have a multiplication right there, which means I can just divide off this 2 to everything. Remember, what I do to here, I have to do to everything. So that reduces that down. And what we're going to be left with, let's just kind of keep going this direction with it, is going to be 1. That doesn't change. So that's going to reduce that 2 out and leave us with x, and then leave us with 6. Notice that here we have an open. Here as well. Okay, so our interval notation would be 1, 6. And if we wanted to graph this, just draw us a number line. Go here, and put a 0 here, then 1, 2, 3, 4, 5, 6. There's my 1. Remember, we're going to have, it's going to be x is greater than 1 with it open, and x is less than 6. So x can be any number, any real number, between 1 and 6, but not including 1 and 6. Let's go ahead and do a different type, because if you'll notice, we've been dealing with less than and less than or equal to. Well, things get a little different whenever you're dealing with greater than. Okay. I want to be very intentional in how I explain this. You're going to notice that, okay, you have, I'm just going to recopy here so you can kind of just see it. You have this x, absolute value of x, is greater than 5. Okay. If you just graphed that, this is what you would have right here. Because we do have the equal sign there, you would have a bracket. And so right here, of course, you would have the greater than. Well, knowing that we're dealing with distance, okay, we need to go ahead and have a negative, I'm going to say, version of this. So you're going to want to have an absolute power of x. Well, let me show you why keeping this symbol and not flipping it would be wrong. If I kept it this way, it would look like that. And that's no-no. You see what's happening here? Now they're both going the same direction. They're not even saying the same thing anymore. So the reason when you have a greater than or equal to, or even just a greater than, you're going to have to flip the signs. So come in here, get rid of that one. So that's why you have this flipping of signs here. Okay? So then you would have the absolute value of x is less than or equal to -5. That's the reasoning for the flipping of the signs. Okay, so I hope that kind of makes more sense. So just remember, this is, you need to look for this when you have a greater than, okay? Let's put it right here. Look for this with greater than. Okay. Let's go down here and do a little example, okay? Because I do want to show you something, a little special case before we kind of end this, and then we'll kind of do some hawks. There are certain circumstances. Now, I want you to be mindful of this. Is while ago, just minutes ago, I talked about if there was a negative sign on the, if there was a negative out there, there's going to have no solution. Well, there is a situation with greater thans. So let's say we have this 3x minus 8, that does not apply. Greater than -6. And just without me saying anything, I'm just going to give you the answer. The answer to this is all real numbers. Okay, real numbers usually is denoted by that. It'd be in your little keyboard screen. Your interval notation is this. And of course, the graph is literally just, here's 0, and it's infinity to infinity. But why? That's the question, why? Well, no matter what number I plug in to x here, okay, I can prove it. If I want to put a 1 there, no matter what number I put in there, it's always going to be greater than that negative, because the absolute value of any number is a distance, it's a magnitude. So even if you have a -6, like right here, let's do it this way. I put a 1 here. So the equation will be 3, 1 minus 8 is greater than -6. Well, 3 times 1 is 3. 3 minus 8 is going to be -5. So the absolute value of -5 greater than -6. Well, is it? Well, what's the absolute value of -5? It's 5. And 5 is greater than -6. And you say, well, what if you put a negative in there? What if I put -1 in there? Okay. Well, then that would be -3 minus 8, which is going to give us what? -11. But what's the absolute value of -11? It's 11. So you can see, no matter what number I put in there, you're always going to get all real numbers. Okay, so there you go.